All right, so today we're going to look at solving a system of equations problem using the substitution method. You look, I've got my system of linear equations already set up right here. I've got one equation in black and one equation in red. And if you think back to what we're actually doing when we're solving a system of equations, we're really trying to figure out when is this equation intersecting this equation graphically. So when are the x's the same, when are the y's the same? So we're really trying to figure out what's going to make that happen. So first thing I notice when I'm looking at this is I notice that this second equation is set up really nicely. It says y equals 2x minus 9. Now what that means for me is that y right here is really the same thing. It's equivalent to 2x minus 9. So anywhere that I have y, I could really say it's the same thing as 2x minus 9. These are the same. Now when I notice this is where the substitution comes in. I notice I have y up here as well. So that y right there, I really want to be the same as this y right here. That's that whole idea of I'm trying to figure out what's going to make these the same. So this y is really the same thing as that y. So I'm going to go ahead and put a blue circle around it. So I can say y is the same thing as y. But I also know that this y is the same thing as 2x minus 9. So what I can then go ahead and write is, I'm going to take this black equation, I'm just going to rewrite this using the fact that everything that's circled in blue is really the same. They're all equivalent. So instead of writing this y right here, I'm just going to write 2x minus 9 because they're all the same thing. So this black equation would then become 4x plus 3 multiplied by 2x minus 9. Notice I'm putting this in parentheses. That's really, really important. These parentheses right here, in place of that blue circle, I'm really putting this blue circle. And notice that circle is kind of setting off the group. It's all kind of one thing. So the 2x minus 9 is this whole big one thing. So there's that blue circle there. Now when I look, this is really nice because what it looks like now is just a linear equation, all one variable, just x's. This is stuff we've solved before. This is stuff you solved this year. This is stuff you solved last year. So this is stuff we're really comfortable with, and that's how I know this method's working out pretty well. So again, just to recap, what I did is in place of this y, I put what y is equal to. Anything that's the same as y, I could replace with y. So this was the same thing as y, so I can replace this y with that. And that's that idea of substitution. So I'm substituting one thing in for another. So at this point, let's go ahead and just finish off this problem. And when I look at this, I want to solve for x. I'm trying to figure out what x is. So I'm going to go ahead and start simplifying. I notice that I can do some distribution here. So I'm going to get 4x, add 3 multiplied by 2x is 6x, 3 multiplied by negative 9 is negative 27, and then I have it equals to negative 7. I'm going to go ahead and then, next thing, I got some like terms there, so I'm going to go ahead and combine those. I'm going to write that down. 10x minus 27 equals negative 7. Thinking back to when I solve an equation, I'm really trying to isolate the variable here. So I'm going to add my 27 to both sides. Show you that. So I'm going to get, so I'm getting rid of that negative 27, so I wanted to add it. So I'm going to get 10x equals, let's see, negative 7 plus 27, so 20. And then last thing, I need to get rid of this multiply by 10 because I'm really trying to find x. So I need to divide by 10 on both sides. And I get, nice and at the bottom, x equals 2. Now, this is part of my solution, but keep in mind, I'm trying to figure out both x and y, because that's really what I was looking for, that intersection, the point that they have in common. So I found that x equals 2. I still need to know what y is. So I'm going to look back up here, and I can really then, it's just like when I'm trying to find a point on a linear equation, I can plug that value in and figure out what y makes it happen. So this 2, I can go ahead and plug in and figure out what the y is on either one of those. So what I'm going to do is I'm just going to plug this one in. I'm going to choose the red one because it's set up really nicely to solve for y. It's already has that beautiful setup for me. So I'm going to go ahead and plug 2 in for x there, substituting. Same thing here, because 2 is the same thing as x, substituting in it. So I get y equals 2 multiplied by 2, subtract 9. So I'm really going to have y equals 4, subtract 9, or y equals negative 5. So really then, this tells me that the point 2, negative 5 is my solution to this system of equations. x equals 2, y equals negative 5 is my solution. And if I want to check this, I can really then go ahead and this point should be on there. We already actually showed that it was. If I want to check it, I could actually take this point and plug it up into the top one as well. And it should work out because this should be a solution to this equation and that equation. It should be on both. And so I'm just going to go ahead and show that really quick. Let's just kind of do an arrow over right here. So 4 multiplied by the x value, which is 2, plus 3 multiplied by the y value, which is negative 5. But it should come out to be negative 7. If we look at this, 8 plus negative 15, and 8 plus negative 15 is indeed negative 7. So we have the solution to the system.